Hello and welcome to all the students of class 11 science. Myself Mr. Amruti from Kankoli College, Kankoli. I am a lecturer in mathematics. In mathematics for class 11th science and arts, there are two parts. The syllabus is divided into two sections, section 1 and section 2. In section 2, the topics are, you can see, number 1, complex numbers, number 2, sequences and series, number 3, permutations and combinations, number 4, methods of induction and binomial theorem, number 5, sets and relations, number 6, functions, number 7, limits, number 8, continuity, and number 9, differentiation. Out of these topics, we shall start with the first topic, complex numbers, today. Friends, so far you have studied and used many types of numbers. We have studied natural numbers in the beginning. See, you are aware of these numbers. You have studied natural numbers. Natural numbers means what kind of numbers? Numbers like 1, 2, 3, 4, 5 and so on. These are also called as the counting numbers. We use these numbers for counting purpose. These are the basic numbers which we have studied, maybe in second or third standard or even first standard. Then the second type of numbers which we discussed were whole numbers. Whole numbers means the numbers like all the natural numbers and one more additional number 1, 2, 3, 4, 5, etc. These numbers, counting numbers or natural numbers are there, and one more extra number, that is 0. This constitutes the whole numbers. So this was the second type of numbers which we discussed or which we studied even in the preliminary part of our studies. Then we saw the next set of numbers, that was integers. Now integers is a set which contains the numbers like, what kind of numbers? It is -3, -2, -1, 0, 1, 2, 3 and so on. Here also you will have infinitely many negative numbers. Here also infinitely many positive numbers. But these are called the integers. They do not contain, means this set doesn't contain the numbers like fractions like half or 0.7 or anything like that, -3.2, etc. These numbers are not there in these sets, even not these sets. So these are the preliminary kind of numbers which we have discussed in our primary education. The other type of number after that which we came across was the another type, which is rational numbers. Rational numbers. Now what are rational numbers? Take any two integers take any two integers like 2 and 3, like 2 and 3, and then divide them, get 2 by 3. This is a rational number. Take any two integers take any two integers like -2 and 1 and get it as -2 by 1, which is also understood as -2 only. This is a rational number. This is a rational number. Again you have, suppose -7 by 8. This is a rational number. Take any two integers and write them in the p by q form. So the numbers in the p by q form where p and q are integers is called a rational number. Out of those p and q both are integers, but q is not equal to 0. You can't take 0 here. Otherwise some may take 3 and the other number q as 0. Then 3 upon 0 is not a rational number, it is something not defined. Understood? So rational numbers means set of all those numbers of p by q type where p and q are integers and q is not equal to 0. Then we turned to the another set of numbers which is called as the irrational numbers. Now this kind of numbers you cannot list, or you cannot write them in a roster form or even set builder form. These are the numbers which you must be knowing. These numbers, the numbers like root 2 or root 3 or root 5 or root 6, root 7, root 8, not root 9. Root 9 is 3, is an integer, root 10, etc. Besides these, we may have seen the number like very special number pi, which is used many times in geometry. Then another number like this, which is e. This is something new to you, but this also is a special number like pi. These special numbers along with these numbers root 2, root 3, even plus or minus, even minus root 2 is irrational, plus or minus, these all numbers are irrational numbers. Now if you see, every natural number is there in set of whole number. So every natural number is a whole number. Every whole number is an integer. Every integer is a rational number like minus 2. A minus 2 upon 1. You can consider 2 as a rational number because you can write it as 2 upon 1. 3 can be considered as a rational number because I can write it as 3 upon 1. P by Q form is the only necessary thing to be for the rational numbers. Then the irrational numbers, this is altogether different kind of numbers. These numbers are not directly related to these numbers. So if you consider in a Venn diagram style, this is a set of natural numbers. Suppose this is a set of natural numbers n. Then the whole number set is a superset of natural numbers w. This set is w is set of whole numbers. Then there is this set. Every natural number is a whole number. Extra number 0 is there. Then we have another bigger set. It is z, which is set of integers. This is set of integers. Then we have every integer is a rational number. So that's a rational number set q. Q is a set of all the rational numbers, and that contains z, that contains w, that contains n. So every natural number is a whole number, every whole number is a integer, every integer is a rational number, and irrational number set is different from this set. Set of irrational numbers is different from this set. Set of irrational numbers. Now, the last kind of set which I have not talked about yet, but you have studied them, is the set of real numbers. Now, what is real numbers? Real numbers set. Now, that real numbers set is nothing but this whole of it. This everything comes in set of real numbers. That means, now if you summarize this everything, these all numbers which we have studied are real numbers. Every natural number you see 1, 2, 3, 4 is a real number. It's a whole number, it's an integer, it's a rational number, it's also a real number. So real numbers set of real numbers is the biggest set that you know of numbers. And after this, even a bigger set will be studied. That set is called as set of complex numbers. This is a set of complex numbers which contains all the real numbers. That means every number, natural number that you know 1, 2, 3, 4 is also a complex number. Every whole number is a complex number. Every integer is a complex number. Every rational, every irrational. All these numbers, every real number in short, is a complex number. Besides these real numbers, there are a few extra numbers which will be there, which are not real but are complex numbers. So the numbers, real numbers that you know, are also complex numbers, and besides these real numbers, there are a few more numbers which together form the real and the non-real numbers. Together they form the complex numbers. So we shall discuss in details what is the complex numbers later on. But for the time being, keep in mind that every number that you know so far is also a complex number. So let's discuss complex numbers in details in the next discussion. So let us start the discussion on complex number. We shall try to understand what is a complex number first. To understand the complex number, or to understand the definition of a complex number, we should know a few more things, few more preliminary things, like one which is called as imaginary unit or imaginary number. Now, what is imaginary unit or imaginary number? I'll ask you a few questions. For example, you know square root of minus 9, square root of 9. Square root of 9 is, it's minus 3 or and plus 3. Both of these are square root of 9. Or even square root of 4. Square root of 4, is minus 2 and plus 2. There are two square roots of every real number. So these are those, except for 0. 0's square root is obviously 0. And now if you think about root of minus 9, what is it? Root of minus 9 is something which you don't know. Think about it. It's not known to you. So you know this root of 9, which is minus 3 or 3, these are integers. Root of plus 4 is minus 2 or 2. Even root of 3 also, this is also known to us. But root of minus 9 is not known to us. These all are real numbers. We know them. These are real numbers known to you, known to us. This is nothing new to us. But this is not a real number. This is not a real number. It's not a real number. And these are the kind of number which we don't know, which are there in the set of complex number. Besides this root of minus 9 type of numbers, there are a few more numbers which you have not studied or which you have not seen. Those will be there in the complex number along with all the real numbers. I told you earlier, all real numbers are complex, but some more numbers which are not real are also complex numbers. So moving towards imaginary unit, what is imaginary unit and why I have written here? See, root of minus 1 is equal to, this is not known to us, that falls in the same category. Root of minus 9 is just something which you don't know. Similarly, root of minus 1 is also not known. This is denoted by iota, Greek letter, or denoted by simply I. This is a Greek letter looking like I. It is called as iota in Greek. So that root minus 1 is denoted by I, and this is called imaginary unit or imaginary number. Imaginary unit it is. And root of minus 9, root of minus 4 can be written in terms of root of minus 1. For example, root of minus 9, I can write root of 9 into minus 1, which is root of 9 into root of minus 1, which is root of 9 is plus or minus 3, I made just 3 in the beginning, and then into root of minus 1 is I. So root of 9 into root of minus 1 is 3i. Similarly, root of minus 4, how do you write this? Write that as 4 into minus 1 in the square root, which is root of 4 into root of minus 1 is I. So it will be root of 4 is 2I. You may write plus or minus. If you start with plus or minus, suppose it is plus or minus root minus 9, then you may write plus or minus 3i. Or simply, if it is just root of minus 9, just write 3i. So 2i. How do you write now? Leave it to you. Root of minus 25. How will you write it? Do it yourself. What is it? Similarly, root of minus 10. This is root of 10 into minus 1. Just split it like this. Then write root of 10 separately and root of minus 1 separately. And out of that, root of minus 1 is known to you. Root of 10 will not change. Into root of minus 1 is I. So root 10i. So every time you may not have the perfect square like 9, 4, 25, 36. May have 10 also. So this way, this imaginary unit is used. Imaginary unit is nothing but I. This is imaginary unit. And these numbers like 3i, 2i, root 10i, these are called imaginary numbers. Imaginary numbers. Because they contain imaginary unit. Imaginary unit is I. So bottom line of the discussion for this brief part is root of minus 1 is equal to I is called imaginary unit. If you square this, you will get minus 1 is equal to I square. So this is an important kind of relation. I square is minus 1. If you take cube of that, I cube is equal to I square into I, which is equal to I square is minus 1 into I, which is minus I. We shall discuss this in the discussion of powers of I. So the important thing for now is to understand what is imaginary unit and what is imaginary number. Imaginary unit is I, which is root of minus 1, and then you can write the numbers like 3i, 2i, root 10i. This, if you have thought about it, is, what is it? It is 5i. This is also a imaginary number. Now we can talk about the definition of a complex number. Take any two real numbers. Take any two real numbers like minus 3 and suppose 2, and use the imaginary unit I, which is I is equal to root of minus 1. That is known to you. Now making use of these three things, you can form this number minus 3 plus 2i. This is a complex number. So for a complex number, you need to have two real numbers and imaginary unit. So I have taken complex real number minus 3, real number 2, and I used I with 2. I got minus 3 plus 2i. Even I can get another complex number from the same 3, 2 minus 3i. Here I have used 2 plus of minus 3 into I. Understood? So suppose I make use of 2 in the beginning and then minus 3 into I. I write in simple manner as 2 minus 3i also. That is also fine. So this is a complex number. This is a complex number. So complex number. So in general, suppose you use two real numbers a and b and make a number a plus ib, bi or ib means the same thing. That is a complex number where a and b are real numbers. They are real numbers. This 3, 2 are real numbers. Like that, a and b are real numbers. They belong to R, and I, as you know, is I is equal to root of minus 1. So the definition is, if a and b are any two real numbers and I is equal to root of minus 1 is the imaginary unit, then a number z, it is denoted by z, is equal to a plus ib is called as a complex number, and it is equal to a plus ib. For example, minus 3 plus 2i or 2 minus 3i or any other number you can try, 4 minus pi I, 3 plus 2i, or even you can have 0 plus 3i, which is simply 3i because 0 is not mentioned, or even minus 2 plus 0i, which is just minus 2. These are, therefore I told you, minus 2 is a real number or in fact integer. Even you can consider that as a complex number. So every real number is a complex number. Now what about this a and b? A is called as a real part of the complex number and b is called as imaginary part of the complex number. Imaginary part of the complex number. So if a complex number a plus ib is given, then a and b are respectively real and imaginary part. Mind it, this b, only b is the imaginary part, not ib. A is the real part. So in this number minus 3 plus 2, what is the real part? In this number, real part is minus 3. And what is the imaginary part in this one? Is 2. 2 is the imaginary part, not 2i. Here what is real part and imaginary part? Real part is 2 and imaginary part is minus 3. In this case, what is real and imaginary parts? Real part is minus 2 and imaginary part is 0. Here real part is 0 and imaginary part is 3. So even you can consider 0. 0 is considered as 0 plus 0i. 0 plus 0i is also in the form a plus ib, where real part is 0 and even imaginary part is 0. Real part is 0, imaginary part is also 0, and that is 0. And therefore 0 is a real number, we know, but it can be also treated as a complex number because it can be written in the a plus. So any number which is written in a plus ib form, where a, b are real numbers and I is root of minus 1, is called as a complex number. A is called real part and b is called like this minus 2 etc. It's called purely real number. So revisiting the matter we studied today, we studied imaginary unit which is I equal to root of minus 1 or even I square equal to minus 1. Complex numbers definition was discussed. Complex number is written in the form a plus ib, where a and b are any two real numbers and I is the imaginary unit. The examples 5 plus 2i etc. are given. Even I is a complex number because it can be written as 0 plus 1i. 3i is 0 plus 3i. Even 0 can be written as 0 plus 0i. 4 can be written as 4 plus 0i. So these are all complex numbers. Some of them are real, some of them are purely imaginary numbers. This is purely imaginary number. This is purely imaginary number. But 4 is a real number. Still all of them are complex numbers. Real part and imaginary part of a complex number. Real part of complex number z is denoted by re bracket z. Z is the letter which is used to denote a complex number. So remember, REZ means real part of Z, IMZ means imaginary part of Z. Now there are some examples, Z1, Z2, Z3, Z4, Z5. These complex numbers are written. What are the real and imaginary parts? Mind you, the real and imaginary part both are real numbers. 5 plus 2i. The real part is 5, imaginary part is 2. Both 5 and 2 are real numbers. So the first case, real part is 3, imaginary part is 8. In the second example, real part is minus 4 by 3, imaginary part is, how do you see that? 1i. It is I means 1i. Real part in this case is, it's written minus 4i plus 3, but you have to read it as a plus ib. That means real part is 3 and imaginary part is minus 4. In this case, 8 is written as 8 plus 0i. That means real part is 8 and imaginary part is 0. This is the pure real number or simply real number. Minus pi I is written as 0 plus minus 5i, and therefore the real part is 0 and imaginary part is minus pi. This is a purely imaginary number. So we shall, in the next lecture we shall discuss the operations on complex numbers. Thank you.